Welcome to the deep dive.
Great to be here.
So today you're doing something really practical. You sent over some practice questions for the Appian Senior Developer exam, the ACD201.
That's right.
And our plan isn't just to, go through the answers. We want to really dig into the why behind them, pull out the core concepts.
Exactly. The idea is to use these questions to quickly grasp key parts of Appian development,
Yeah.
like a fast track to understanding the essentials.
Perfect for someone trying to get up to speed efficiently. So just for context, the ACD201, it's 50 multiple choice questions. You get 60 minutes, costs $200, and you need a 60% to pass.
Right, so the stuff we're covering is directly relevant.
Okay, let's dive in. First question you shared was about Appian sites. It asks, what is the primary benefit of using a site in Appian applications?
And the correct option was C, to present a tailored navigation experience.
Right, so why that one? Why is the tailored navigation the primary benefit? Seems like they might do other things too.
They do, but this really gets to the heart of why you'd build a site. Think about the default Appian environment. It's powerful, but it can have, well, a lot of navigation options visible. Yeah, like the design tools, admin consoles, everything potentially.
Exactly. A site lets you completely hide all of that default stuff and present the user with only the pages, tasks, and reports that are relevant to their specific job or role.
Ah, okay. So it's about focusing the user, cutting out the noise.
Precisely. It creates a clean, dedicated experience. If someone's job is just approving expense reports, their site might only show their task list and maybe a link to submit their own reports, nothing else.
That makes a huge difference for usability, I bet. Less overwhelming.
Absolutely. Reduce distractions, users find what they need faster. It directly impacts how efficiently people can use the application.
So the key takeaway is, think of sites as creating these focused mini applications or portals within the bigger Appian platform.
That's a great way to put it. Dedicated, user-friendly portals. That's the core value. Got it. Okay, let's move to the second question. This one's about process model optimization. It asks, when designing a process model, which configuration helps reduce long-running instances? And the answer is A, use of asynchronous subprocesses.
Right. This touches on a really important concept for system health.
So what's the difference? Synchronous versus asynchronous.
Okay, so think of a normal synchronous step in a process. The process gets to that step, does the work, and only then moves on. It waits.
Right, step by step.
But an asynchronous subprocess, it's different. The main process reaches the point where it needs to call the subprocess. It basically tells the subprocess, go do this thing, and then the main process immediately continues on its way.
It doesn't wait for the subprocess to finish.
Nope. The subprocess runs independently in the background.
Okay, I can see how that helps avoid waiting. When would you actually use that? What kind of tasks?
Well, think about anything that might cause a delay. Maybe you need to wait for a user to actually complete a task, like an approval. That could take hours or even days.
Right, you don't want the whole process just sitting there idle.
Exactly. Or maybe you're calling an external system, like a third-party API, and you don't know how long it will take to respond. Or sending a large batch of notifications.
Ah, yeah, external calls can be slow sometimes.
Definitely. If you make those calls asynchronous, the main workflow keeps going. The subprocess handles the waiting or the slow external task on its own.
So the benefit isn't just speed for that process, it's about reducing the number of processes that are just hanging around waiting.
Precisely. Fewer active idle instances means a healthier, more efficient system overall. Keeps things clean.
Okay, makes sense. Key takeaway. Use async subprocesses for things that might hold up the main flow.
You got it. Especially waits or external interactions.
All right, question 3. This one's about designing expression rules.
A core skill.
The question, which design pattern is most effective for minimizing expression rule duplication? The answer is B, modularizing logic in separate rules.
Yes. This sounds like basic good coding practice, right? Don't repeat yourself.
Yeah, DRY principle. But how does it play out specifically in Appian expression rules?
So imagine you have a complex calculation, maybe determining a customer's discount level based on several factors. You might need that logic in an interface, maybe in a process model, maybe in a report.
Okay, multiple places.
Right. Instead of writing that whole calculation logic out in each of those places, you create one separate expression rule that does just that calculation.
Ah, a dedicated rule for the discount logic.
Exactly. And then from your interface, your process, your report, you just call that one rule.
So reusability is the big win here.
It's huge. But it's not just that. Think about maintenance. What if the discount rules change?
Oh, right. If it's modular, you only change it in that one rule.
Exactly. You change it once, and it's instantly updated everywhere it's used. If you'd copied and pasted the logic everywhere, well, good luck finding and updating every single instance correctly.
Yeah, that sounds like a recipe for bugs. Inconsistent logic.
Absolutely. So modularizing makes your application more consistent, way easier to maintain, and less prone to errors.
So the takeaway is, break down logic into small, reusable expression rule building blocks.
Perfect analogy. Build with focused blocks.
Okay, question 4 takes us to Appian data store doors.
Connecting to the database world.
Good question. What is a key use case for using data stores in Appian? And the answer is C, mapping process variables to database tables.
Right. This is fundamental for dealing with persistent data.
So what is a data store in Appian terms? Is it the database itself?
Not quite. Think of it as Appian's connection and mapping layer to an external relational database. You still have your actual database like SQL Server or Oracle or whatever running separately.
Okay, so the data store is the bridge.
Exactly. And a key part of that bridge is defining how your Appian data structures, your custom data types or CDTs.
GTs, right. Those define your data fields in Appian.
How those CDTs map to the tables and columns in your actual database. You're telling Appian, this field in my CDT corresponds to that column in this database table.
And why is that mapping so crucial?
Because it allows Appian processes to read data from the database and, importantly, write data back to the database persistently.
So the data doesn't just vanish when the process ends.
Correct. It gets saved in the database via the data store mapping. This lets you store historical process data, query it later, use it to build Appian records for users to view and interact with, generate reports. Basically, everything you need to do with structured, persistent data.
So without data stores, your process data is kind of temporary.
Largely, yes. Data stores are the mechanism for durable storage and interaction with your enterprise databases.
Got it. Key takeaway. Data stores are the bridge linking Appian CDTs to external database tables for persistent storage.
You nailed it.
Cool. Question 5 moves to the front end. Sale interfaces.
The user experience layer.
The question asks, which best practice should be followed when building interfaces with Sale? Answer C. Use local variables for performance optimization.
Performance. Always important for the UI.
We mentioned variables earlier with expressions, but how do local variables specifically help in Sale?
Okay, so when a Sale interface loads or updates, Appian has to calculate the values for all the components. Right? What text goes where, what data populates a grid, should this button be visible, etc.
Right. It evaluates all the expressions defining the interface.
Now, imagine you have a calculation or maybe data fetched from a rule that you need to use in multiple places on that interface. Maybe you display a total value at the top and then use that same total in a chart later down the page.
Okay.
Without local variables, Appian might end up recalculating that total value every time it's referenced as the interface renders or refreshes.
Which could be inefficient, especially if the calculation is complex or involves querying data.
Exactly. It adds up making the interface feel sluggish. Local variables, defined with a .local variables, let you calculate that value once when the interface loads or when specific inputs change.
And then you store it.
You store it right there within the interface's scope. Then, everywhere else you need that value, you just refer to the stored local variable. Appian doesn't have to recalculate it.
So it avoids redundant computations within the interface lifecycle.
Precisely. It makes the interface load faster and feel much more responsive, especially complex ones or those hitting integrations.
Makes sense. Key takeaway. Use local variables in Sale to compute values once and reuse them, boosting performance.
Definitely. A key optimization technique.
Okay, question 6. Back to integrations. How can you optimize integration calls? This one asked for 2 answers.
Right, multiple choice, multiple answers sometimes.
The correct ones were A, enable response caching for GET requests, and D, use asynchronous calls where applicable. Let's take caching first. Why specifically for GET requests?
Well, GET requests, by definition, are generally used for retrieving data. They're meant to be safe and idempotent, meaning calling them multiple times with the same parameters should return the same result and shouldn't have side effects.
Okay, like fetching a customer's details, asking again should give the same details, assuming they haven't changed.
Exactly. So if you're fetching data that doesn't change very often, why go all the way back to the external system every single time you need it within a short period?
Seems wasteful.
It is. Response caching lets Appian store the response from the first successful GET call. if another identical request comes in within the cached duration you set.
Appian just serves up the stored response without calling the external system again.
Bingo. Huge performance win for Appian, less load on the external system, faster interfaces, faster processes.
Nice. Okay, what about the second part? Using asynchronous calls, we talked about async subprocesses. Is this the same idea for integrations?
Very similar concept applied to calling external systems. If you make a synchronous integration call, your Appian process, or sometimes even the user interface, literally stops and waits until the external system sends back a response.
And if that system is slow?
Your Appian process is stuck waiting. Your user might see a loading spinner that just goes on and on. Not great.
Yeah, frustrating.
An asynchronous integration call, however, lets Appian fire off the request to the external system and then immediately continue with its own work.
It doesn't wait for the response right away.
Correct. You typically configure a way to handle the response later. Maybe the external system calls back into Appian, or Appian checks back later. But the key is Appian isn't blocked.
So it improves responsiveness, especially if the external system might take time.
Absolutely. Keeps things flowing. So the takeaway for integrations: cache, YEET, requests for data that doesn't change rapidly, and use async calls when you don't need an immediate response to avoid blocking.
2 solid optimization tips. Got it. Question 7, environment-specific constants.
Deployments, a critical topic.
The question asks about the benefit, and the answer is C. They enable easier deployment and configuration. Why is this such a big deal?
Okay, think about a typical application lifecycle. You have a development environment, a testing or QA environment, maybe UAT, and finally production.
Right, different stages.
And each of these environments will likely need different configurations. The database connection URL will be different in dev versus prod. API keys for external services will be different, maybe email server addresses.
Yeah, definitely don't want dev pointing to the production database.
Exactly. Now, if you hard-coded those values like the actual database URL directly into your Appian objects,
you'd have to manually change them every single time you deploy from dev to test, test to prod.
yes. And that's incredibly tedious and super error-prone. It's so easy to forget one or typo one and break the application in the new environment.
I can see that. So constants fix this.
Environment-specific constants do. You define a constant, say, DD connection URL.
Mm-hmm.
Then within Appian's admin console, you provide a different value for that same constant for each of your environments.
Ah, so the constant name stays the same, but its value changes depending on where it's deployed.
Precisely. When you deploy your application package, Appian automatically picks up and applies the correct value for the target environment. No manual changes needed in the code or objects.
That sounds way smoother and safer.
It is. Massively reduces deployment errors and saves a ton of time. Key takeaway: use environment-specific constants to manage configuration differences across environments automatically.
Essential for sane deployments. Okay, question 8 is about record actions.
Acting on your data.
The question: in which situation would you use a record action? Answer: B. To generate a new process instance for a record.
Right. This is a core pattern in Appian. Records give you a view of your data, often bringing information together from different places.
Like seeing a customer's details, recent orders, and support tickets all in one place?
Exactly. Now, a record action is a button or link typically placed directly on that record view that lets the user initiate a business process related to that specific record.
So if I'm looking at customer X's record, I might have a record action button like log new support ticket?
Perfect example. Or update contact info, or initiate order refund when you click that action.
It kicks off a process model.
Yes. It generates a new instance of a process model that's designed to handle that specific action, like creating a new support ticket. And crucially, it usually passes the context, like the customer ID, from the record you were viewing into that new process instance.
So the process already knows which customer the ticket is for. Very efficient.
Very. It connects the user's view of the data directly to the relevant action or workflow for that data. It's low-code automation in practice.
Key takeaway: record actions let users start processes directly related to the specific record they're looking at.
Spot on.
Almost there. Question 9, performance bottleneck identification.
Finding the slow spots.
Which feature helps identify and resolve performance bottlenecks? Answer: C, performance view in Appian Designer.
This is your best friend when things feel slow.
So what does it actually show you? How does it help pinpoint problems?
It gives you a really detailed breakdown of what's happening under the hood when an interface loads or a process runs. For a sale interface, it shows how long each component each layout, and critically, each rule or query evaluation took.
Down to the individual piece, milliseconds and all.
Yep. You can literally see, this rule evaluating the user's permissions is taking 500 milliseconds, or this grid query is taking 2 seconds. It highlights the slowest parts.
And for processes?
Similar idea. It shows the execution time for each node in the process model. You can see if one particular script, task, or integration call is taking way longer than everything else.
So it takes the guesswork out of it. You see exactly where the time is being spent.
Exactly. No more guessing. You get data. You see the bottleneck, whether it's a complex expression, a slow query, or an inefficient interface structure, and then you know exactly where to focus your optimization efforts.
Invaluable tool. Key takeaway. Performance View is the go-to diagnostic tool for finding and fixing slow parts of your Appian app.
Absolutely essential for optimization.
Okay, final question. Number 10. Application packages.
Bundling it all up.
What is the purpose of application packages? Answer, C, to bundle application components for deployment.
We touched on this with constants, but this is the core mechanism.
So it's more than just the constants, it's everything.
Everything related to your application. Your interfaces, your rules, expression rules, integration rules, decision rules, your process models, your data types, CDTs, record types, groups, data stores. Basically, all the design objects you've built.
You group them all together into one package.
Correct. You define an application, add all the relevant objects to it, and then you can export that entire application as a single package file.
And the main reason is for moving it between environments, like from dev to test.
That's the primary purpose, yes. It ensures that you move all the necessary pieces together. It prevents you from forgetting a crucial rule or an updated CDT when you deploy.
So it guarantees consistency between environments.
It helps guarantee it, yes. It dramatically simplifies the deployment process, export one package, import one package, and makes change management much more reliable. Avoids missing dependencies.
Okay, so key takeaway. Application packages bundle everything together for consistent and reliable deployment across environments.
Couldn't have said it better myself. It's fundamental to the Appian development lifecycle.
And maybe, was there one specific area today, maybe async, maybe modularity, maybe caching, that sparked a new question or an idea you want to dig into more on your own Appian journey? Something to definitely think about.
Always more to learn.
Indeed. Well, thanks for joining us on this deep dive.
My pleasure.